Okay, so converting between radians and degrees. Okay, there are going to be some times that you're going to be given angles that are in what we call radian measure. It does not mean you change your calculator to be in radian mode. It's just, basically the idea is that when you convert from degrees and radians, it's like converting from feet to inches or something like that. They're equivalent lengths, equivalent angles of rotation, just different units of measure. So if you think about a circle, all of the angles in a circle, or if I rotate around a whole circle, that whole rotation is a rotation of 360 degrees. If I have something with, like, let's say the circumference of the unit circle, remember the unit circle has a radius of 1. My circumference of the unit circle would be 2 pi times 1, or just 2 pi. So for me to go around a whole circle, I'm going to go around 360 degrees. As I go around a whole circle, that's the same thing as rotating around 2 pi units. So therefore, 360 degrees and 2 pi are the same thing. 2 pi is actually a radian value. Okay, so technically that's like your conversion rate. Again, like 12 inches is 1 foot, or like 2 cups in a pint. 360 degrees is 2 pi radians, or if I reduce that, divide everything by 2, 180 degrees is equal to pi radians. That's really our conversion rate. Okay, so what you're going to do is you're going to multiply by this conversion rate to be able to change from degrees to radians or radians to degrees. If you want to convert from degrees to radians, you're going to multiply by pi over 180. Okay, so for example, look at the first problem. I have 225 degrees. When I multiply this by pi over 180, you're actually not going to multiply the pi. You're just going to reduce 225 over 180. So the easiest way you can do that, type in your calculator 225 divided by 180 and hit math frac. And then that comes out to be 5 over 4. So this converts to be the radian value 5 pi over 4. If it happens to be a negative answer, don't worry about changing it to a positive or anything like that. You take negative 315 to convert it to radians, multiply by pi over 180. You're going to leave the pi on the top. Negative 315 divided by 180, hit math frac, comes out to be negative 7 pi over 4. Okay, if I want to convert from radians to degrees, okay, I'm converting backwards, I'm going to multiply by the reciprocal of this conversion factor, by 180 over pi. So for example, if I have 3 pi over 4, I'm going to multiply that by 180 over pi. What's nice is that those pi's are going to cancel out, and then I just have to do 3 times 180 divided by 4, and I find out this is actually equivalent to 135 degrees. Okay, so one more time. I have a radian value. You'll know because it's in terms of pi. I'm going to multiply it by 180 over pi. These pi's will cancel. I do negative 7 times 180 divided by 2. And that comes out to be negative 630 degrees. Okay, so I know that's not really a useful angle for you right now. Eventually we'll talk about how if you want to turn that into an angle, you'll eventually be able to you'll do stuff with like adding and subtracting 360, but for right now, we're just strictly converting between units. All right, so finding exact values of trig functions in the coordinate plane. Okay, it's not going to be just as simple as finding the sine of 45 or the cosine of 60. Okay, I will say though, all of your exact value stuff is still going to come from the unit circle and the special right triangle. So you need to have these memorized. On the unit circle, remember you have CVS. Okay, that tells you what the coordinate, that tells you the cosine and the sine. Remember that your angles of rotation always start on the right-hand side at 0, rotate to the top to be 90, to the left to be 180, to the bottom to 270, and eventually back to 0, which is also 360. Okay, if we get values that end up being negative values, we'll convert them into useful angles between 0 and 360. If they're too big, we'll do the same thing. If they're in radian measure, we'll convert them to degrees and again turn them into a useful angle between 0 and 360. If something falls on the quadrant, you use these coordinates. If it falls within a quadrant, you'll find a way to relate it back to a 45 or a 30 or a 60. Okay, so you must have these memorized. So finding the exact value of something like the sine of 210. So what I would say is the first thing you should do is make an ASTC chart and locate your angle. Where is 210 located? Okay, as I rotate around here, around the unit circle, you can see 210 falls between 180 and 270. So 210 falls in the third quadrant. So the question is, how do I now relate this back to one of these special right triangles? This is clearly not one of the quadrant angles. That would be one of those points. What you need to do is find out the reference angle. The reference angle is the amount of angle that it takes to get back to the x-axis. Okay, so it's either going to be compared to 0 and 360, or on this side to 180. So you have to ask yourself, if I go back to the x-axis, what degree value am I going back here? What's the difference between 180 and 210? The difference is 30 degrees. That means that the sine of 210 is actually going to be the sine of 30. Now, a really important thing to check before you start pulling values off your triangles, look at what quadrant you're in. You're in the tangent quadrant. Is sine supposed to be positive? No. So that's why this is really a negative sine of 30, okay? So you locate your angle, you figure out your reference angle, okay? You decide if it's positive or negative, and then you go and you pull your information off your special right triangles. So here's 30, the sine of 30, sine is opposite over hypotenuse is 1/2. So the exact value of the sine of 210 is negative 1/2. If you take a look at question number 2, tangent of negative 135. Right now, this is not a usable angle for us. So what we're going to do is we're going to add 360 to that angle. You either add or you subtract 360, depending on if it's too big or, in this case, too small. When you do, negative 135 plus 360, that adds up to be 225. So what we're doing here is we're really finding the value of the tangent of 225. Okay, so I make an ASTC chart, and I'm going to start by locating my angle. Where is 225 located? 225 is located between 180 and 270 in the third quadrant. In the third quadrant, you're always doing, again, with respect to the x-axis, how far back do I go to 180? So between 180 and 225, that's a difference of 45 degrees. That means this tangent of 225 is really the tangent of 45. Again, all of your exact values relate back to your special right triangles, or if they fall on an axis, the unit circle. In this quadrant, you're in the tangent quadrant, so tangent should be positive. I would put that in there for emphasis to make sure that you've checked. The tangent of 45, my 45, 45, 90. Tangent is opposite over adjacent, so opposite over adjacent is 1/1, which comes out to be just positive 1. If it happens that you're given a radian value, really not too much more than what you just did before, except you have to convert that radian value into degrees. So remember, we talked about converting from radians to degrees. To convert from radians to degrees, you multiply by 180 over pi. Okay, those pi's will cancel. 5 times 180 divided by 4 comes out to be 225. Okay, and that means you're really finding the cosine of 225 in this case. So similar to the last question, 225 falls in the third quadrant, okay? How far away from the x-axis, reference angles are always done with respect to the x-axis, how far away from the x-axis is 225? That would be 45 degrees. So this is really the cosine of 45, but remember that you're in the tangent quadrant, so that has to be a negative cosine of 45. You go to your special right triangles. Cosine of 45 is adjacent over hypotenuse, so that's negative 1 over radical 2. I can't leave it as negative 1 over radical 2. I have to rationalize that. So I times top and bottom by rad 2 over rad 2, and I get negative radical 2 over regular 2. Okay, and then the last one, tangent of 9 pi over 4. Okay, so 9 pi over 4. Okay, take that, multiply that by 180 over pi. So cancel out those pi's. I get 9 times 180 divided by 4. And this comes out to be the tangent of 405. All right, so 405 is too big of an angle for me here. So from 405, I'm going to minus 360. 405 minus 360 is 45. And this comes out to be just the tangent of 45. So I don't technically even need to do an ASTC chart here, but I'll do it anyway. When you have something that falls in the first quadrant, the reference angle is the angle that you're given, okay? And it's already positive when you're in the first quadrant, so I can literally just go right to my special right triangles and say tangent of 45, opposite over adjacent, 1/1, comes out to be 1. Just to throw an extra exact value in here somewhere, so I'll put number 5 over here. Suppose that I was asked for something like, I don't know, the tangent of 180. 180 is not something that's going to fit in an ASTC chart because it falls on the actual quadrant itself, okay, on the axis. If you remember that tangent is really sine over cosine, what we would need to do is take the sine of 180 and divide by the cosine of 180. So where do we get those values from? This is where the unit circle comes into play. You go to 180, remember CVS, this is your cosine, this is your sine. We're taking the sine of 180, that's the y-coordinate, and dividing by the x-coordinate, -1, and 0 divided by -1 comes out to be 0. That's how you'd end up using the unit circle to get an exact value. You would just locate whatever angle you're going to and grab the x or the y coordinate, or in the case of tangent, you take the y divided by the x, and that's how you'd be able to get your exact value. All right, so finding exact values of reciprocal functions. I once again want to remind you that all of your exact values, whatever function you're working with, come from the unit circle or the special right triangles, okay? So the unit circle, all the points on the unit circle, remember that each point is cosine comma sine, or the special right triangles, you must have them memorized. When you do reciprocal functions are things like secant, cosecant, cotangent. You're basically talking about taking a sine, a cosine, or tangent and flipping it over. 1 over cosine, 1 over sine, 1 over tangent, which, by the way, remember that tangent is sine over cosine, so the reciprocal of sine over cosine is cosine over sine. Any one of those can be used for secant, cosecant, and cotangent. The way to remember that secant goes with cosine and cosecant goes with sine is to remember the phrase no co. Okay, cosecant does not go with cosine, okay, no co. Just like an extra little phrase to remember. All right, so if you are given a point on the unit circle, really important that it's on the unit circle, that point is the point cosine comma sine, okay? State the value of all 6 trigonometric functions. So we're talking about what is sine, what is cosine, what is tangent, and then the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent, okay? So we're just gonna be taking the originals and flipping them over. So sine is our y-coordinate, CVS. The y-coordinate is radical 3 over 2. The cosine is the x-coordinate, which is 1/2. And then the tangent, remember, is sine over cosine. So I'm gonna take rad 3 over 2 and divide it by 1/2. Those 2's cancel out, and I'm left with radical 3 over 1, which is really just radical 3, okay? Then I'm going to be taking the reciprocals of each of these functions. So I'm going to take this and flip it upside down. So 2 over radical 3. I can't leave it with a radical in the denominator. I have to rationalize it. Radical 3 over radical 3 gets multiplied to the top and the bottom, and this becomes 2 radical 3 over 3. Then I have cosine is 1/2. 1/2 gets flipped over to become 2 over 1, okay, or just 2 is totally fine. Tangent of theta is radical 3 over 1. I flip this over, and this becomes 1 over radical 3, which I have to rationalize, which becomes radical 3 over radical 3, or radical 3 over 3. Okay, so you're just taking your original trig functions and you're flipping them upside down. For the secant of 60, okay, so when you see something like secant of 60, right underneath it I want you to write the reciprocal of, secant is the reciprocal of cosine, the reciprocal of cosine of 60, okay, and at the bottom I want you to write the word flip so you remember to actually do that reciprocal. So to find this exact value, I'm pretty much just going to find the value of the cosine of 60. So going back to our reference information, cosine of 60 adjacent over hypotenuse would be 1/2. Okay, it's positive because you're in the first quadrant. You could do an ASTC chart, but you don't technically need it for this first one. But don't forget you have to flip that. So you flip that over to become 2 over 1, and that's your value for the secant of 60. When you have the cosecant of 300, you're going to write that as the reciprocal of, cosecant is the reciprocal of sine of 300. Don't forget to write the word flip, so you don't forget to flip at the end. To find the value of the sine of 300, that's where you're going to use your ASTC chart. 300 is located in the 4th quadrant. It has a reference angle of 60. So this is really going to be the sine of 60. Now in the 4th quadrant though, cosine is the only thing positive, so it's going to be a negative sine of 60. Okay, sine of 60. Once again, go to your reference information. Sine is opposite over hypotenuse. So that's a negative radical 3 over 2. To finish getting cosecant, though, I have to remember to flip it. When I flip it, it will stay negative. When that radical goes in the bottom, I'm going to turn that into radical 3 over radical 3. So negative 2 rad 3 over regular 3. If it happens that you have a radian value, it's not too much different. You still start by taking that 3 pi over 4, convert it to degrees, and then go through all the same steps we've been going through before. Multiply this by 180 over pi. Okay, so that 3, those pi's will cancel. 3 times 180 divided by 4 is 135. So I'm finding the cotangent of 135. Okay, as soon as you see it's a reciprocal function, I want you to write the words reciprocal of cosine tangent of 135. Okay, at the bottom write the word flip so you don't forget, and now you go through and you find the value of the tangent of 135. So you make an ASTC chart. You're in the second quadrant because 135 is in the second quadrant. Now you're going to have to find your reference angle. Your reference angle here is with respect to 180, always with respect to the x-axis, is actually 45. So this is going to become a tangent of 45. In the second quadrant, sine is negative. Sine is the only thing positive, so tangent is negative. And then tangent of 45, again, go back to your reference information. Tangent of 45 is 1 over 1. Okay, when I flip that, that actually stays negative 1 over 1, or just plain negative 1 by itself. Okay, and last but not least, this is kind of a little bit of putting everything together in this problem. Negative 4 pi over 3 gets converted to a degree value, so times it by 180 over pi. So I do negative 4 times 180 divided by 3, because those pi's cancel, and I get negative 240. All right, so secant of negative 240. Negative 240 is not a usable angle for me right now, so I'm going to add 360 to it. So this becomes the secant of 120. You're dealing with a reciprocal function, so you're going to write it as the reciprocal of cosine of 120. Okay, and don't forget at the end to write the word flip. So let's find the cosine of 120. I take my ASTC chart. I'm in the second quadrant. I figure out how many degrees I am away from the x-axis, always the x-axis. This comes out to be 60. So this becomes the cosine of 60, but in the second quadrant, that should be negative because only sine is positive. The cosine of 60, you go to your reference information. Adjacent over hypotenuse is 1/2. And finish by flipping this over to get negative 2 over 1. And that, like I said, is a little bit of putting everything together. But again, all of your exact values come from your special right triangles or the unit circle.